Okay, let's look now at the difference between means, or what you're trying to estimate is the difference between population means. The parameter then will be mu A minus mu B, the difference between the population mean in group A and the population mean for group B. And then the statistic will be the difference between the two sample means, or x bar A minus x bar B. While I'm at this point, let me make sure you can distinguish between this problem and the matched pairs test. This is two separate groups. A and B might be male and female. A and B might be one group of people who received training, and B would be another group of people who did not receive the training. So it's two separate groups. If you remember back from the last exam, the matched pairs is two measures on the same person. So one person you measure the performance of one person once, then you do something, maybe some training, and then you measure that same person's performance again, so a pre-test, post-test. And in that case, you could just think of that as, once you got the differences or the improvement, as a one-sample t-test. So remember, in that case, you just have really one sample with, say, a pre- and a post-test measure for each person. This is actually two different groups, males and females, trained and untrained. And of course, there are many other examples of that. So in the problem at hand, hopefully you've printed this out, we want to know if males and females differ in their perceived, or average, population mean perceived political skills. And so we have a sample of 200 male undergraduates and 200 female undergraduates. And one of the reasons I want to make sure I put this here is that once you do have your results, you have to be careful about generalizing those. Maybe we can generalize them to male and female undergraduate students, but we should be very careful about generalizing those beyond male and female undergraduates. And this particular study also happened to be done at a southern university, so this might not even be generalizable, or at least you need to think about whether or not that would be generalizable to male and female undergraduates at other universities, or universities that are not in the South. I'll let you fill that in and with your own. So here's just some items on that political scale inventory that was used in the study from which I assimilated this data. And you can just kind of read through those and see what they are. I will add here that this 7-point Likert scale, named after Rensis Likert, the guy that came up with this type of scale, and you've seen these before, going from strongly disagree to strongly agree, or at least more than half assume that you've seen scales like this at some point or another. Just a list of statements, and with each statement, the statement is rated from 1 to 7, or from strongly disagree to strongly agree. So again, we want to know if there's a difference in the average perceived political skills for males and females. And by average there I mean population mean. If we get sample means, there's a very high chance that there's a difference between sample means, and we can just compute that. So our interest is the difference that we observe something that could be due to random error, or is it very unlikely to be a function of random error and instead indicate a real difference between population means. Again, the null hypothesis is always equal, that the population is equal for females and males, and HO is that they're not equal. And you can see that I could have done this with both of them, but it's particularly, I think, important with the null hypothesis to restate that as mu F minus mu M, or you could say A and B. I thought it would be more understandable in this case to call it F for female and M for male, but you can call it A and B if you want. But to put mu f minus mu m equal to 0, because when we draw the sampling distribution later in the problem, then the center of that sampling distribution will be 0. As with other problems we've done, the p-value rejection statement, or the decision rule here, is always to reject HO if the p-value is small, and we'll say that we have a level of significance of 0.05. So here's just some summary statistics and a box plot. And I'll go ahead and tell you for the assignments you're working on that the box plot is something I got from R, and that hopefully is pretty easy to do by now. And the sample statistics I got from JASP, and if you haven't watched my video on that, you should. It's really easy to get a table exactly like this that you can just copy and paste into, at least for this class, just copy and paste into an assignment. And they're set up exactly like you would need even if you were going to publish that in an academic journal. It's also, I think, easy to read. And you can see that we have, for each group, male and female, the sample size, the mean, and the standard deviation. And then the standard error, which some people include on their tables, and I will just because it's on JASP, but some people don't, because and you can think of that as redundant information, because I could have just taken the standard deviation and divided by the square root of n, in other words, numbers that are already on the table, and gotten the standard error that way. I also drew a graph for this that's a dot plot or a strip chart. It may not look like dots right now. That's because there's a bunch of them, and so I had to make them small. You can't use this if you have a continuous variable, but when I did my simulation, I had to do this as exactly 1, 2, 3, 4, 5, 6, or 7. That made it come out to be a discrete variable. It's maybe a little easier to see what's going on in the data if you can have a dot plot like this. And you can see that when we're looking at this, that males seem to be skewed to the right, with a lot of people at the 1, 2, and 3 level. Lower perceived political skills. Now let's keep in mind, that doesn't mean they have lower political skills. It means just that they perceive or report themselves to they report that their perceptions are that they have lower political skills. And as you get for females, you can see maybe a little bit more to the right, maybe and less skewed. And more people, like if you just look at the 5, 6, and 7, more females on those categories than there were for males. That's just to get a picture or visualization of the data from the problem. So now, there's the information that was in the table. If you're on an exam or you're going to use this with your calculator, select Stat, Test, and 2-sample t-test, and then fill in the chart with the appropriate means and standard deviations and sample sizes. With a 2-sample t-test, you will not need to specify a null hypothesis. It assumes that the null is that it's equal to 0. It will also ask you a question about whether or not you want to pool or not pool, and I'll make some more videos on this where that is relevant. With sample sizes of 200, that's really not it just doesn't make any difference. And when you have small samples, like if we were taking 10 or 15 in each sample instead of 200, it will make a difference, and we'll get to that in another video. So you just select either one, and make sure you select not equal to, since we just asked if there was a difference, and then you should end up with results like this. That t of 4.93 means that we're almost 5 standard deviations away from the null hypothesis of 0. Our difference, x bar a minus x bar b, or x bar f minus x bar m in this case, would be 3.345 minus 2.59. second here and I will calculate that. So that'll be 0.755. So our sample statistic is 0.755, which is just x bar A minus x bar B. So anyway, that's 5 standard errors away from what you would have if there were no difference. And the p-value, remember that has to be between 0 and 1. It says 1.18. That's a clue that this is going to be something in exponential form. So when you see that e to the minus 6, put 5 zeros before you get to the 1. Another number to pay attention to on here is this on the second screen here, just above the sample size, the SXP. That's the standard deviation that's pooled for the two groups, and we'll need that when we compute effect size. So at the bottom there we have the standard deviations for the two groups that we have, and you can see that up here at the top from our table. That's just reproducing that. That's the numbers that we entered. And then those are pooled to get an estimate of what you would have of all of the data together. And so that p-value, I'm just going to call that 0.000001. Of course, you could have put 118, but it's little, and it's less than 0.05, so we're going to reject HO. And conclude that the population means differ. Could go on to say here that this means that there's a difference in the population means for males and females in terms of their perceived political skills. Could even be more exact and say there's a difference between the population mean political skills for male and female undergraduate students at a southern university. We hope that certainly the contention of the authors of this study would be that it goes beyond that, but we should keep that in mind as well. So our effect size, get that back over here, there we go. We had our SXP of 1.53, so we had the difference between the two sample means. That's the statistic. I could put minus the hypothesized parameter, minus mu A, minus mu B at the top there. Looks like I switched from female and male here, but so you could say instead of x bar A, F and M. But the difference between the two sample means our statistic minus the hypothesized difference, but that was 0 and always will be, so I'll just put the x bar A minus x bar B there, divided by the standard deviation. And that'll give us the 0.49, which is a medium effect. That'll be the same rules that we used on the last test. Remember the 0.3, the 0.5, and the 0.8 for small, medium, and large effects. Again, I'm going to reemphasize that when we computed the test statistic, the t-value, we would have the same numerator, but instead of having standard deviation, we would have standard error. And I'm not going to go into too much detail in this video or in the videos I'm making this semester, but I do have some videos that you could use or look at it if you want to that would go into more detail on how that standard error was calculated. So the t was on the bottom would be standard error. For the effect size, it's just the standard deviation. The reason you would do the effect size, well, the reason you do the t-test is to get, is this likely to happen by chance? The effect size gives you a better idea of how large the effect is without being affected by the size of the sample. You can get differences in probability. The larger you get in your sample, the smaller and smaller the standard error gets. So with the same difference in sample means, you'll get different t-values depending on the sample size. The Cohen's d or other measures of effect size are not affected by the size of the sample, and just give you a more, what I would call, practical, in fact they'll talk about the practical size of the effect. Again, this cutoff of 0.5, or the cutoffs that Cohen suggests, should only be used in what I would call exploratory research or new research. If you have more experience with what you're studying, you should use things that you define in the context of what you're studying. In some cases, maybe a smaller effect would be something that would be meaningful, maybe in some medical context or something like that. So here's our sampling distribution. We have the statistic x bar A minus x bar B. That's the distribution that we're doing. And the center is our null hypothesis, mu A minus mu B is equal to 0. And then the 0.755 was the difference between our two sample means, the 3345 minus 2.590. And since it's a two-tailed test, we have to go the same distance in the other direction. So if we go 0.75 this way and 0 is the center of it, we'll go the same distance, or just down to minus 0.755 on the other side. So now, putting that into words, if mu A minus mu B is equal to 0, if HO is true, by the way, I could put if mu A is equal to mu B, that's an equivalent statement, then there is a p-value chance that x bar A minus x bar B, our statistic, is either greater than or equal to 0.755 or less than or equal to minus 0.755. So now for our confidence interval, we'll do a 95% confidence interval. Just reproduce the statistics that we had before. We're going to do stat test 2 samp t interval, and you'll end up with 0.454 to 1.056. Please verify that you can get that same number if you're given these, that you can go to your calculator and get these values for the limits of the lower and upper limits of your confidence interval. That will be particularly useful, which I hope will make you happy during the exams, especially when you have a multiple choice question. Speaking of multiple choice questions, there may be a question that asks you for the margin of error. So that's the statistic x bar A minus x bar B plus or minus the margin of error. And so the center of that interval, the x bar A minus x bar B, is 0.755. We've done that a couple of times now. So this 0.454 to 0.1056 is 0.75 plus or minus a margin of error. So to get the margin of error, you can just get the difference between 1056 and 755. Or you could get the difference between 755 and 454. Either one of those will work. Or you could, alternatively, do 1056 minus 0.454 and divide that by 2. Any of those will get you the margin of error. Okay, 0.301. I see that I missed one thing there, and I'm going to go back and get that. Before I do, I'll just remind you, that is the margin of error is 0.301 in this problem. 3 ways to get here. Here's one of them. Take the upper limit and subtract the statistic itself, and that'll give you the margin of error. Moving back a little bit. Since 0 is not in the interval, we can conclude that there's a difference between the population means. Sorry, I skipped that before, but certainly that's the way to evaluate confidence intervals for the difference between population proportions is to look to see whether or not 0 is in the interval. In fact, for 3 of the problems we've worked on so far, the matched pairs t-test, the two-sample t-test, and depending on which order you watch the videos, the two-proportion z-test, in all of those cases, to evaluate confidence intervals, you look to see whether or not 0 is in the interval. There was the other way to get the margin of error. I said that but didn't put this up here. That was just the upper limit minus the lower limit divided by 2 would give you the margin of error. So I'm going to show you here, and this is, I think, particularly relevant for any kind of assignments that you're working. Again, this is JASP, just another statistical program or package. And this you can get by just selecting some radio buttons. This would be, in addition to the sample statistics, a full set of output with everything you need for inference. It has the t-values, the p-values, the difference between the two, the standard error of the difference. You can see that on your calculator. That was the SXP, Cohen's d, and the confidence interval all in one place. For this class, especially, well, I would just say for this class, a lot of times I'm going to give you output. I might give you this on an exam. You can see at the bottom here, before I get to that, let me just say that you could just report this row or this row, and you can see that they're exactly the same in this case. That's because we have a pretty large sample sizes, 200 in each group. But you can see down here, Levine's test, this is a test that tests to see whether or not variances are equal. If you remember on your calculator, it asked you whether or not you should pool, and that has to do with yes or no. Well, you pool if you have equal variances. You don't pool if they're not equal. So this says we have a violation of the equal variance. So technically you should be using the bottom row in there because this assumed equal is being violated, so you should use this. That really is only going to be relevant in a practical sense when you have small sample sizes.